Are you ready?
Okay, I'm back again.
I have questions. Are you going for like a regular presentation?
Just give me a second. Let me introduce the topic. I already have it.
What? What the fuck?
Okay, this week's my presentation this week is the basics of packed malware. Pretty much, you guys probably know what a malware is, and sometimes when you get a malware, it's always packed. It's hard to reverse engineer it. So, and sometimes the authors try to mess up the way they pack the malware, so you have to manually unpack it. Well, today we are gonna look at how to the basic of how packers work and how to potentially unpack them manually. You can always write a tool to do it for you, but okay, here we go. The meme of the day. I think I'm gonna start doing this now. I know, I was bored, so I'm pretty sure everyone has gone through this. So that's it. Okay, again, blah blah blah. Same as last time. Blah blah blah. Not a fanboy. I wait till last minute to do my work, and the goal to answer your question, Jason. My goal is to beat Shannon's score, which is 13, and this is my number 10. So I have 3 more to go. Yes. Okay. This is not my face. First we have to start with what packing is, and it's obviously not the going to vacation kind of packing. It's packers. Well, in the world of malware, malware, it is the way of compressing your binaries to a smaller size, or just making it of putting it in a obfuscated state, so it's hard for reverse engineers to reverse it, and also difficult to detect. So trying to bypass antivirus fun stuff. Again, it's compressed or obfuscated, yeah, yada yada stuff like that. There are two type of packers out there. There's the compressing one, which they just reduce the size of the binary, so it's easy for you to move over. And there's the encrypting packers. So they, rather than reducing the size, they just obfuscate, and they just encrypt the code itself. So still the same size, just different. Probably like they changed the variable name and all that fun stuff. Wow, it's going quicker than I expected. So there are type of hackers out there. The most one we know is UPX. This meme has nothing related to this. It was just there. Uh, UPX, the Unite American Package System Service. There was a joke for that. I'm sorry. UPS. That's what I was going for. Yes. UPX is the most common one. In if you're taking CSEC 202, a fundamental of reverse engineering, you would definitely see this a lot. There's the second one. There's the Impress. There's the FDG. I think I spelled that wrong. That's wrong. But there's multiple packets out there, but UPX is the one most people go to. And you don't always have to use any of this. You can always write your own packet if you want to try to be really go under the radar. You can always write your own stuff. So how does this work? This question is really broad because again, there's different type of packets out there, and they have different ways of doing the packing. But in this case, we are going to use UPX because it's the most popular one. So so there's two parts. There's your binary itself, and every time you pack your malware, the UPX adds a new PE header, so that defines like where the new entry point would be. So the entry point is where the code first starts running. So that the new PE header, there'll be a picture after the slide. The new PE header will contain a lot of this information, and the stub, which is the unpack, it's at the bottom, which it's pretty much the on the reverse. It kind of unpacks the malware. So when you execute your malware on a machine, the stub unpacks the malware and does all that fun stuff. So this is the image. So the packer, well, the original one, and when you pack it, it uses some magic. That's the magic in the middle, and you have the new P other and the stub. The stub is the unpacker. So those two are needed. And what most malware authors do is you can just like pack your malware and just do this and that'll be fine. But they try to again make it really hard to reverse and they mess with this p header and by changing like a byte or something, or even changing the magic byte of the p header so it's not a UPX header. I think there's a picture about that. Oh, right here. So the new P header contains two structs. It has the L info and the P underscore info. I was actually doing there was another presentation about malware I was reversing, and while trying to do it, there was the author changed the P the P underscore info by changing the file size. The file size is again the size of the whole binary, and they changed that, so it was kind of hard for the UPX decoder to actually unpack my malware. So I had to go in there into the bytes world, and I had to edit the size of the binary to be the same as the block size. But I think I'm gonna do this later. But for now, the new P header would contain L underscore info and P underscore info. And those two are important for PE for the UPX to unpack your malware. Okay, the stub. What does it do? Again, it contains the entry point, which points to the main function. Well, before, if on your original malware, the entry point will point to your main function. But after you pack your malware, the entry point changes to the stub section, the unpacker, which tells the decoder that this is where you have to go to unpack the malware. It's a lot of back and forth. And the stub again unpacks the malware, and after it unpacks it, it has to write that data, the encrypted the original executable. It has to write it somewhere. So it has that it I think I kind of moved this all over, but the stub writes the unpacked data into a new location and a new memory location. And after that, the original executable gets to run as intended. So just to reframe, the entry point points to this unpacker, then it unpacks it using some magic. Then while it's doing that, it has to write that data, so the original executable, to a new location in memory, by the way. And from there, the machine can now the stub points to the new to the original executable. So the new points to the main function of that executable, and then runs as intended. So like that. Hopefully this makes sense. This is just summarizing what I've said so far. Or maybe better. So let's say you have sample.exe. It's a packed malware. How do you know if a binary is packed? Well, you can always look at the PE headers. Those are always a good step. Uh, but there's always multiple indication of a packed malware. These are the common ones. First of all is the lack of imports, because for every executable you need imports. Like you need the kernel 32.dll and one second and the msvcr.dll, just like important DLLs. And in those DLLs, you obviously need more functions. But in this case, you get less than usual. So that's one indication. And another part is the names, the section names. In an original executable, you get like .data, .text. .text is the where the code is, where you wrote your code. That's where it goes. And there's the .rsrc, which is I believe is your resource folder. So things like images and stuff like that. But when you have a packed malware, it becomes again, the packer changes the PE header, and that becomes UPX0, UPX1, and UPX2, and that is a big flag that it's packed. And if that doesn't show anything, if you look at the size, the raw size versus the virtual size, that's also going to help. If the virtual size is greater than the raw size, that means that, well, again, it's packed. The virtual size is pretty much what? It's memory. It's the what I think I have it somewhere, but the virtual size is just when you execute it, that's what it uses in memory, and the raw size is how much it takes on your host machine. So like on the on your computer. And again, there's also the permissions privileges. On a normal binary, you don't have a write and then execute in the same place, but in a packed one, you usually have read, write, execute privileges. That's another red flag. And the last one is if your binary is jumping to some random memory that you don't have access to, that's also indicator. It can also tell you that that's where the original executable is going to get written to. So those two, that these steps kind of help us identify if a malware or if an executable is packed. I have no demo, but we're going to do a walkthrough of a malware sample. So these are the steps we're going to go through. We're going to look at the PE headers and verify again that it's packed. Locate the data, the address of where the unpacked data will be written to. So in the UPX0, it tells you the address area and tells you where the data is going to get written to. And look for any jump and call references in the assembly. And we can set a jump point at that, a breakpoint, sorry, a breakpoint at that jump or call instruction, just so we can extract the data right from memory. And again, just dump the data to run it. This, oh yeah, I'll get to that as I go there. Uh, so there is multiple tools to view your PE headers. There's PE Bear, BEAR. I think I say it somewhere. Yeah, right there, PE Bear. It tells you, it pretty much visualizes the PE header for you, and you can see all that beautiful information. But yeah, as you can see, we see that the imports is just two DLLs and not a lot of imports. And again, if you see like virtual protect, kind of tells you that it's packed because usually there's more, and virtual protect is memory related. So that's that. Again, the headers, you can see UPX0, UPX1, UPX2. Usually it's .data, .text, and other ones. And the strings, just basic static analysis, just running strings. It can also give you a lot. In a normal executable, depending on how big it is, you get a lot of strings, mostly ASCII things you can read. So like HTTP headers or a URL. But if it's packed, you just see random stuff and things that doesn't make sense for the most part. So PE headers, you want to see the size of those. You can use, there's multiple tools for this. You can use PEID, PE beer, the word right there, and there's multiple. So right from this image, you can see that the virtual size is greater than the raw size. And like I said, the virtual size is the space allocated during runtime. So when you execute it, this is the space it has. And the raw size tells us how big the section is going to be on your local machine. Uh, they should be equal or at least a little bit different, but not by so much, because how much space you have in memory should be the same as you have on your computer. So this, the first UPX0, that's a red flag. And the empty memory size, I think I forgot to put a picture. No, right here. The UPX0 has this information. Again, first of all, it has writable and executable, red flag. Second, it tells us this address, the 0x0040100000. That's weird. It doesn't seem that we have access to it, because when you go there, all we see is empty bytes. So what we can assume from this is that's where the unpacked data we get read into. So we need to keep a lookout for this address area. Next to that, after that, we look at UPX1, and we notice that the entropy is pretty high. So there's probably a lot of data right there. So that's probably where the packed data is. So that's one thing. And we can also go to that address, the 41000. And right around that area, we can see a lot of jumps to random addresses. So in this second image at the bottom, we can see it's going to 4012D0. And that's interesting because we have this previous image which has the starting address to be 401000. So that confirms the assumption that 4010s would be where the data is being written to. So we have, again, still have to keep an eye on that. And yeah, I think that's it for this one. So this is what that area looks like. The it's just a bunch of empty data, empty bytes, nothing. But after we run the pack, we let the packet do its stuff to unpacking the data. We notice, wow, now there's more readable and more data, and we can see that that's like a starting point of a function. That's the new entry point of our executable. This is our executable. So now we have unpacked this data and we've written it in memory. Now we need to dump it out so we can have our own exe that's not packed. Oh, that was pretty fast. Oof. Okay. In OllyDBG, there's a plugin called. Wow, I didn't write the plugin, but there's a plugin. I forgot. I thought I wrote a plugin for this, but there's a plugin that if you put in the address, the new entry point, which in our case is 12D0, this number right here, we can just put that right there and just dump it. When we dump it out of memory, we get a new executable. And if you run that executable, you get this beautiful message, which is, hello, this is a native C program compiled on the command line. And that's yeah, I'm sorry, I'm blanking out. We have successfully dumped this malware or executable from the packed version. So I'm pretty sure I didn't explain any of this correctly. But if you really want to go in detail, this is where I was reading the article, the first one. I don't know if it shows. Well, no. For people not here, 1 second. Let me share my whole screen. If you click on the first link, you get directed to this page. This is where I got all the information. Because again, I was using this when I was doing my reverse stuff, and this is really important to look. So you can read this, and if you want to watch, there's a video on this too. If you click on this, there's this video. You can always watch it. Not okay. No. But yeah, you can watch this service stuff because I was watching service. But yeah, you can always go to click on the third link and you can watch this person actually unpack it from memory. So that's that. And it's over, and thank you for your attention. I'm sorry. I always wake up to like 5 to start my presentation, so I always lose brain cells after that. So yeah, that's it. Any questions? Please don't have questions because I don't know what I was saying. Okay, it doesn't seem like there's any question on Twitch, so I don't think there's anyone watching too. Is that a question?
One question.
Where's the question? I cannot see. Very good. We have one last presentation, and it is mining crypto with virus total. Woof! Woohoo!
Ooh.
I can do it. Yeah. What the?
It's on the screen. You have to
Hit 10.
move it.
Hit 13. Hit 15. I want that.